Good morning. So we're gonna begin this video by picking up where we left off talking about operating on polynomials. Now, if you remember, we talked about operating on polynomials with addition, subtraction, and multiplication, and those were pretty straightforward. They really weren't anything difficult. The one operator that we left out though is division. Turns out dividing is a little bit tricky, and I'm actually going to show you two ways. And so this is where things get a little bit difficult. The first way I'm going to show you, I would like you to take down the notes, but it's not the way that we're going to focus primarily on. It's called long division. I'm going to show you a faster version of this, but in order to really appreciate the fast version, I need to show you the original long version. And so let me first begin by showing you how to do long division by dividing this polynomial, 3x cubed minus 2x squared plus 2x minus 5, with x minus 2. This is going to take a little bit long. Do not be concerned if it's confusing. For those going into pre-calc or algebra 3, you'll get more practice with this next year, but it's just one of those things that takes a while for you guys to really understand. So here's how long division works. You set it up as a simple division problem. You probably haven't seen something like this since, middle school, but the idea is very simple here, okay? What we want to do is divide the leading terms of the first polynomial into the leading term of the second polynomial. So what do I mean by that? The leading term here is 3x to the third, and I'm going to actually divide that with this leading term x. And so that gets me 3x squared. That 3x squared is the first result of part of our answer that we're going to record up here, 3x squared. So that's your first answer. The answer I'm going to do here is in red. That's the first thing you do with that. The second thing you're going to do is we need to reduce this here so that we can continue dividing. And to do that, we're going to take the 3x squared and we're going to multiply it into here. So 3x squared times x minus 2 gives me 3x cubed minus 6x squared. And after I multiply that into the x minus 2, I record my result right underneath here. And by the way, this isn't normally how I would be showing it in class. In class, I would do a much more methodical lesson, but I want to be wary of time here. So I'm leaving all that part out. But let's get back to this. So after you multiply this into here, and you recorded it down here, what you're going to do is subtract everything here. So when you subtract everything here, what ends up happening is the signs end up flipping because we're distributing the minus. So the first term cancels out, and that's actually what we want. The reason why we multiply this back into here is so the first term can cancel out. And then we combine these x squared, which gives us 4x squared, and I just bring the rest of the terms down. So really, what you're going to now do is basically, what you're really doing now is you're actually dividing x minus 2 into 4x squared plus 2x minus 5. So we're now going to take the leading term of our new polynomial here, 4x squared, and then we're going to divide it by this leading term here, x, which just gets me 4x. And I put my 4x up here. Okay. What we're going to do next is, just like before when we took the 3x squared and multiplied into here, we're now going to take the 4x and multiply it into here. So literally, I'm going to take the 4x and multiply it into x minus 2, which gets me 4x squared minus 8x. And I record that right down here. By the way, although this looks very complicated, there is a pattern to this. Some of you might be picking it up. Really, it's just 2 steps repeated over and over again. But from here, again, we minus everything, so we flip the signs. The first term cancels out, which is what we want. We want it to get smaller. And then we combine the x's. So that gives me 10x minus 5. And there's one last thing to do. You take the leading term of 10x, and you divide it by that x over there, which gets you 10. And you record the 10 up here, and then again, you multiply the 10 back into the x minus 2, which gets you 10x minus 20. Flip the signs. First term cancels out, perfect, and that leaves us with 15 here at the end. This last number, that is your remainder. But really, that's all there is to this. That's it. This is your final answer. So when we divide x minus 2 into 3x cubed minus 2x squared plus 2x minus 5, our result is 3x squared plus 4x plus 10 with a remainder of 15. And that's really all there is to long division. Actually, it's much shorter than I thought it would be. But again, in class, I would typically show it in a much longer method with, trying to get all the kinks here and there. But if this confused you, don't worry too much about it. The second thing I'm going to show you is much, much, much more important for you guys, for Algebra 2. But this is long division. If you want practice with this, you certainly can. It's actually very useful in pre-calc. But in Algebra 2, we don't use it as much because there's a faster way of doing this. Just one more quick disclaimer, by the way. We don't typically like to write our answer the way I wrote it. We like to write it as a quotient. So the better way of writing this is to actually write it as 3x squared plus 4x plus 10 plus 15, divided by x minus 2. We just put the remainder as a fraction with this x minus 2 on the bottom. And that's really all this thing up here is saying, is that we can take any quotient and rewrite it as, the quotient plus the remainder divided by the divisor, which is all I did here. Again, if this confused you, no biggie. I just wanted to show it to you guys just to kind of cover the base that we did go over it. The most important thing is going to be this right here called synthetic division. Synthetic technically means fake, but there's really nothing fake about this. Technically, this method actually works for any polynomials, though some teachers will say it only works for linear terms. It actually works for any real terms, any polynomials with real coefficients. So the way synthetic division works is I'm going to show you the process here, and I would like you guys to try it for at least one or two of the problems at the end here. But 4, 3, 2, 1, 4, 3, 2. Okay, so I should do this one. You guys can do number 5. I'm going to do all these 6 examples here with you guys. I'm sorry, 5 examples here with you guys. But synthetic division is very easy, but it does require you recognize a pattern. So let me go over this first one here. Again, it's called synthetic, but there's really nothing fake about this. It works for any polynomials. So this could be, a complicated x squared, for example, and this would still work. It just requires a lot more work is the only problem. But let me just get straight into the meat of this, okay? Cutting out all the middleman. Here's how synthetic division works. If you're going to divide x minus 2 into this term here, what you do is this. We set up an upside down division bar. And then we put the opposite of this minus 2 here as positive 2. We always flip the sign out here. And then what goes inside of here are the coefficients from this. So what are the 4 coefficients? Well, the first one is 1. The second one is 2. The third one is -6. And the fourth one is -9. Okay, that's how you set it up. That's it. That's all you have to do to set it up. To actually perform the process here, it's the same way we always do it. It's the same first step. You always begin by bringing this 1 down here. And by the way, our answers are going to be down here. But you bring the 1 down here. The second step is you multiply the 1 and the 2 together. So you multiply these 2 numbers out here. So what's 2 times 1? That's 2, and you record it up here. Okay, so let me just backtrack. So you take the 1 and the 2, and you multiply to get 2. So the first step, let me actually record this. So your first step is you bring it down. The second step is you multiply it. And the third step here, you add what's inside of here. So what's 2 plus 2? That's 4. Okay. I hope those 3 steps made sense because we're going to repeat the process. Now what do? You take the 2 and you take the 4 and you multiply them. 2 times 4 is 8. And then you add the insides. -6 plus 8 is 2. Then you multiply the 2 and the 2. Gets you 4. Then you add the inside, and that gets you -5. And that's it. That's really all there is to it. From there, you pretty much have your answer. This is the setup for our answer, but we have to add something that we kind of took out of our work. We have to add the x's. So here's how this works. Each of these represent a coefficient. The last number represents a remainder. And To attach the x's is actually very easy. You just put 1x squared plus 4x plus 2. Okay, that might seem a little bit confusing, so let me backtrack. You put 1x. The degree you're going to put is always going to be a degree less than the 3 up here, because we're dividing by an x. So what's a degree less than 3? Well, that's 2. And then from there, you just kind of decrease your degrees. So the next degree after 2 is going to be 1, and the next degree after x is going to, or I'm sorry, after 1 is going to be 0. So your actual answer is going to be 1x squared plus 4x plus 2. Remember, anything to the 0 power becomes 1. And you have a remainder of negative 5. And that's it. Or, better yet, should write it like this. Either answer I'll take for now, it doesn't really matter, but in pre-calc, this is definitely the better answer. Okay, that might seem a little bit confusing. Let me try a few more examples. I'm gonna get decreasingly verbose as we go over these, just to kind of illustrate the point about how easy this is to do without much discussion. But let's now divide it by x plus 3. So I do the same thing. I set up an upside down bar, I put the opposite of plus 3, and I put the coefficients inside of here. The coefficients do not flip. None of the signs here flip. They are the same signs as the problem. The only thing that flips is this plus 3 right down here. That's it. Okay, first step, bring down the 1. Second step, multiply the two numbers outside. Third step, add straight down. And you repeat the process. Multiply that. Add these two. Multiply this. And add these two. Okay. Now tomorrow, the next lesson we're going to talk about is what happens if you have a remainder of 0. This is actually very special. But for now, all you have to know is that it's a remainder of 0. That's it. How do you write your final answer? Where you put 1x squared, because I have a degree less than this, minus 1x minus 3. Or for those that want to see the full, I guess, work explained, 1x to the first minus 3x to the 0, 2, 1, 0. Or better yet, x squared minus x minus 3 with a remainder of 0. So if you want, you could put this, but it's not necessary. And that's it. Okay. I know it's confusing. I'm definitely going to ask you guys to give number 5 a shot, but I'm going to do 2, 3, and 4 with you guys. But what I recommend, if you guys want to, you guys can put these on mute and just kind of watch the way I do this. You will notice a pattern if you haven't already done so. I promise you this is not as hard as it looks. It's just hard because you're doing this at home by yourself, and I'm sorry for that. But let me do number 2. Opposite of plus 1 and the coefficients. You bring this down, multiply, add, multiply, add, and you're done. The last number is your remainder. Easy peasy. You just got to attach your x's. 4x, not to the second, not this time. It's 4x to the first because remember, we start with a degree less than that one up there. So it's 4x1 plus 1x0 with a remainder of negative 5. Or 4x plus 1 with the remainder of negative 5 over x minus 1. Choose blue. Again, all I did, took the opposite of minus 3, took the coefficients here, and my first step is to bring the 3 down, this 3. My second step is to multiply these two numbers, and then my third step is to add straight down. And then I repeat the process. Multiply, add straight down. If this stuff confuses you, just let me know. We can talk more about it, but again, your credit really comes from you just taking down the notes. Your final answer, And that's it. Okay, the last one's a little bit tricky. The last one, first of all, starts at x to the fourth, so we're going to have to do a little bit more work. But there's one quick disclaimer about this. In order to do synthetic division, or even long division for that matter, all of your x's have to be accounted for. So what I mean by that is this. I have 10x to the fourth, I have 5x to the third, I have 4x to the second, but I'm missing an x here. Can you guess what x I'm missing? I'm missing x to the first. So to do this, what I have to do is first put the 0x here as a placeholder. I have to account for that missing x. Otherwise, my work is going to skip a step, and it's going to give us a wrong answer. So you have to include that 0 there. Once we do, we just set everything up. -1, 10, 5, 4, 0, and 9. Again, that 0 is this 0 that I had to put here. So you have to manually insert that in there in order for this to work. And then from there, you just do your stuff. Bring that down, multiply, and add. Let me just make sure I multiplied correctly because I feel like I screwed up. That looks good to me. Okay, so now comes the big part, remainder. That's 10x to what degree? To the third. And then now we just decrease that degrees for each term. Honestly, I think adding the x is probably the most confusing for students learning this brand new. But that's really all there is to it. Okay, if you guys can give number 5 a shot, but I really do want to see the notes for these guys, so make sure you send them to me when you guys can. If you have any questions, concerns, I bet a lot of you are confused by this, please just give me an email. Again, I am simply grading you on whether or not you took the notes down, not whether or not you understand this. That will come for a quiz, and when that happens, I will obviously give you much more leeway than I would in class. But if you are confused, definitely let me know. But I really hope you guys understand it. Again, send me a picture when you're finished. Thank you.